In the summer of 1943, B-17 bombers were falling from the sky over Europe at an alarming rate. Not from enemy fire, not from pilot error. They were coming apart in mid-air, their wings folding like paper, their fuselages splitting open. Crews died without ever seeing the enemy that killed them. Engineers were baffled. The B-17 Flying Fortress was supposed to be the toughest bomber in the sky. It was designed to take punishment that would destroy lesser aircraft. Yet something was causing catastrophic structural failures that no one could explain. The answer came from the most unexpected source imaginable, not from MIT-educated engineers, not from experienced test pilots, not from the aircraft designers who had built their reputations on the B-17. It came from a 19-year-old factory girl who had never finished high school. This is the story of how the women of America's war factories didn't just build the weapons of victory, they made them better. They found the flaws that killed their brothers and husbands and sweethearts. They saved lives that the experts didn't know were at risk. And this is the story of one woman who saw what the engineers couldn't see because she was looking at the problem from a place they never thought to look. Her name was Margaret Sullivan, from a small town in Kansas. She was 18 when Pearl Harbor was bombed, working as a waitress at a diner near the highway. Like millions of young women across America, she answered the call when the war plants started hiring. Margaret had never seen the inside of a factory. She had never touched a power tool. She had never read a blueprint. What she had was something the engineers didn't. She had fresh eyes. She saw things that people who had been doing the same job for years had learned to ignore. The Boeing plant in Wichita hired her in February 1943. She was assigned to the wing assembly section, where hundreds of workers installed the components that would hold B-17 wings together. Her specific job was riveting, driving metal fasteners through aluminum skin and structural members to create the wing's outer surface. It was hard work. The riveting gun weighed 8 pounds and vibrated constantly. The noise was deafening. The aluminum shavings got everywhere. By the end of a shift, her arms ached and her ears rang, and her coveralls were streaked with grease and metal dust. But Margaret paid attention. She noticed things. She asked questions that annoyed her supervisors. She wanted to understand not just what she was doing, but why she was doing it. She wanted to know how all the pieces fit together. Her brother was a tail gunner on a B-17 somewhere over Europe. Every rivet she drove, she thought about him. The Boeing Wichita plant was a miracle of industrial organization. At its peak, it employed over 30,000 workers and produced more B-29s than any other factory in America. The assembly line never stopped. Day shift flowed into night shift, flowed into day shift again, an endless cycle of construction that turned raw aluminum into flying fortresses. Workers came from everywhere. Farmers from the surrounding plains, housewives from Wichita neighborhoods, young women from small towns across Kansas and Oklahoma and Missouri. Most had never worked in manufacturing. All learned their jobs on the fly, trained by the workers who had come before them. The training was rushed by necessity. There wasn't time to explain the engineering principles behind every task. Workers were taught to follow procedures, to meet specifications, to keep the line moving. Questions were discouraged. Production was everything. This approach worked remarkably well. American factories produced aircraft at rates that astonished the world, but it also created problems. Workers who didn't understand why they were doing something couldn't recognize when something was wrong. They followed procedures even when the procedures were flawed. Margaret was different. She didn't just follow procedures, she thought about them. 3 months into her job, Margaret noticed something that bothered her. The wing spar, the main structural beam that gave the wing its strength, had a row of rivets along one section that didn't look quite right. The spacing was uneven. Some rivets were closer together than others. She mentioned it to her supervisor. He glanced at the work and shrugged. "That's within tolerance," he said. "The inspectors passed it. Keep moving." Margaret kept moving, but she kept watching. Over the following weeks, she saw the same pattern on wing after wing. The rivet spacing in that one section was always inconsistent. Sometimes the variation was small, sometimes it was larger, but it was always there. She asked questions. Why was the spacing inconsistent? The answer was that the section required workers to rivet in an awkward position, reaching around a structural member that blocked direct access. It was physically difficult to maintain consistent spacing when you couldn't see what you were doing. Everyone knew this. Everyone accepted it. The tolerances were set to accommodate the variation. The inspectors checked that the rivets were within acceptable limits, and they always were. The procedure was working as designed, but Margaret couldn't stop thinking about it. Something felt wrong. In the spring of 1943, reports started coming back from Europe. B-17s were experiencing structural failures at an unusual rate. Wings were cracking, fuselages were splitting, aircraft that should have survived were falling apart. The failures weren't happening in combat. They were happening during routine maneuvers, during takeoffs and landings, during flights that should have been completely safe. Crews reported hearing strange sounds before the failures, creaking and popping noises that preceded catastrophic collapse. Boeing sent engineers to investigate. They examined wreckage. They reviewed maintenance records. They analyzed flight data. Nothing made sense. The aircraft were failing at stress levels far below their design limits. Something was fundamentally wrong, but no one could identify what. Back in Wichita, Margaret read about the failures in company newsletters that were posted in the break room. The newsletters didn't give details, but they urged workers to be extra careful, to double-check their work, to report anything unusual. The tone was worried. Margaret thought about the rivets, the ones with the inconsistent spacing, the ones everyone said were fine because they were within tolerance. She started doing something her supervisors definitely would not have approved. She started keeping notes. Margaret spent her lunch breaks watching other workers. She watched how they handled the difficult section on the wing spar. She watched how the variations accumulated. She noticed something that no one else had thought to look for. When workers riveted that section, they naturally compensated for the awkward position by applying extra force. They had to in order to get the rivet gun into the right angle. But the extra force sometimes pushed the aluminum skin slightly out of position before the rivet was set. The skin would then be under tension when the rivet locked it in place. This wasn't visible to inspection. The skin looked flat. The rivets were properly set. Everything appeared normal. But the metal was stressed in a way that the original design hadn't anticipated. Margaret wrote down her observations in a notebook she kept hidden in her locker. She didn't know if she was right. She had no engineering background. She couldn't do the calculations that would prove or disprove her theory. All she had was what she had seen. She tried talking to her supervisor again. He told her to focus on her job and stop asking questions. She tried talking to the line inspector. He said the rivets were within specification and there was nothing to discuss. Margaret was a 19-year-old girl from a Kansas farm town. The engineers had degrees from MIT and Caltech. The inspectors had years of experience. Who was she to question them? But her brother was still flying missions over Germany. Every day she went to work, she wondered if the B-17 he was sitting in had the same flaws she was seeing in the ones rolling off the line. American war plants had suggestion systems that allowed workers to submit ideas for improving production. The systems were designed to capture the practical knowledge of people who actually did the work every day. Good suggestions were rewarded with cash bonuses and public recognition. In June 1943, Margaret submitted a suggestion. She wrote out everything she had observed as clearly as she could. She described the rivet spacing variations. She explained the compensating force workers applied. She hypothesized that the aluminum skin was being pre-stressed in a way that could lead to fatigue cracks over time. She expected to be ignored. Suggestions from assembly line workers about engineering problems were rarely taken seriously. The engineers knew better. That was why they were engineers. But her timing was fortunate. Boeing was under enormous pressure to solve the structural failure problem. The Army Air Forces were losing aircraft and crews at unacceptable rates. Engineers were grasping for any lead that might explain what was happening. Margaret's suggestion landed on the desk of a young engineer named Robert Chen. Unlike some of his colleagues, Chen actually read the suggestions that came from the factory floor. He found that workers sometimes noticed things that engineers missed, simply because they spent all day looking at the actual product instead of drawings and calculations. Margaret's suggestion intrigued him. Her observations were specific and detailed. Her hypothesis made a certain kind of sense, and it pointed to a failure mode that the engineers hadn't considered. Chen went down to the factory floor. He found Margaret and asked her to show him what she had observed. She took him to the wing assembly section and demonstrated exactly what happened when workers riveted that difficult section. She showed him the subtle variations that accumulated across dozens of rivets. Then Chen did something unusual. He brought a strain gauge and measured the stress in the aluminum skin after a wing section had been riveted. The readings were higher than expected. The metal was indeed under tension that wasn't supposed to be there. He ran the numbers. The pre-stress from assembly, combined with the stress from normal flight operations, pushed the metal past its fatigue threshold much faster than the design calculations had predicted. Wings that should have lasted thousands of flight hours were failing after hundreds. Margaret was right. A 19-year-old girl with no engineering education had identified the cause of failures that had killed dozens of airmen and baffled the best minds in American aviation. The fix was relatively simple once the problem was identified. Boeing redesigned the access to that section of the wing spar, adding a small cutout that allowed workers to see what they were doing and rivet without applying compensating force. The change added perhaps 10 minutes to the assembly of each wing. More importantly, Boeing issued a technical bulletin to all units operating B-17s. Aircraft already in service were inspected for signs of the fatigue cracking Margaret had predicted. Many showed early signs of the problem. They were repaired before the cracks could spread to catastrophic failure. Margaret received a cash bonus of $50, the standard reward for a suggestion that was implemented. She also received a certificate of appreciation signed by the plant manager. Her name was mentioned in the company newsletter, though the details of her discovery were kept vague for security reasons. The recognition was modest considering what she had accomplished, but Margaret didn't care about recognition. She cared about her brother, who was still flying missions over Germany. She cared about all the brothers and husbands and sons who sat in B-17s and trusted that the aircraft would bring them home. Her brother survived the war. He flew 31 missions and came home in 1944 with a Distinguished Flying Cross. He never knew that his sister had probably saved his life and the lives of countless others by paying attention when everyone else had stopped looking. Margaret's story was one of thousands. Across America's war factories, women workers discovered problems, invented solutions, and improved production in ways that the official histories rarely recorded. They were supposed to be temporary workers, filling in until the men came home. Instead, they transformed American manufacturing. At the Douglas Aircraft Plant in Long Beach, a woman named Esther noticed that the fixtures used to hold aircraft components during assembly were causing small scratches in the aluminum. The scratches were within tolerances, but she suspected they might be starting points for fatigue cracks. She was right. Douglas redesigned the fixtures with rubber padding. At the Consolidated plant in San Diego, a woman named Dorothy found that a particular batch of rivets was slightly harder than specification. They were still within acceptable limits, but they required more force to set, which was tiring workers and slowing production. She traced the problem back to a supplier who had changed heat treatment procedures. The batch was replaced. At the Willow Run plant in Michigan, a woman named Helen invented a simple tool that held small parts in place during assembly, freeing both hands to work. The tool saved an average of 3 minutes per assembly operation. Multiplied across thousands of operations per day, it significantly increased production. These women weren't engineers. They weren't supervisors. They weren't supposed to think about the big picture. They were supposed to do their jobs and keep the line moving. Instead, they used their eyes and their minds and their common sense to make American war production the most effective in history. There's a reason why fresh eyes often see what experienced eyes miss. Expertise creates assumptions. Engineers who had designed aircraft for years assumed that their procedures were correct. They assumed that tolerances that had always been acceptable would always be acceptable. They assumed that problems would show up in calculations before they showed up in reality. Workers like Margaret had no such assumptions. They saw what was actually happening, not what was supposed to happen. They noticed variations that experienced workers had learned to ignore. They asked questions that seemed naive but revealed hidden problems. The women also had a motivation that many of the engineers lacked. The engineers were building aircraft. The women were building aircraft that their husbands and brothers and sons would fly into combat. Every rivet, every weld, every assembly was personal. Failure wasn't an abstract engineering problem. Failure meant someone's husband wasn't coming home. This personal connection drove a level of attention and care that no training program could instill. Workers who might have been indifferent to production quotas became passionate about quality when they understood that lives depended on their work. After the war, Margaret returned to Kansas. She married a veteran who had served in the Pacific. She raised 3 children. She never worked in a factory again. But she kept the certificate of appreciation, the $50 bonus stub, and the clipping from the company newsletter in a box in her closet. Her children grew up hearing stories about the war years, but Margaret rarely talked about her own contribution. She didn't think of herself as a hero. She thought of herself as someone who had done her job and paid attention. Anyone could have seen what she saw. She just happened to be the one who spoke up. In 1994, a researcher working on a book about women in war industries found Margaret through Boeing's records. The researcher interviewed her about her experience. Margaret was 70 years old, a grandmother, living in the same town where she had grown up. Asked what she remembered most about her time in the factory, Margaret didn't talk about the discovery that had saved lives. She talked about the fear, the constant grinding fear that something she did wrong would kill someone. The nightmares about rivets coming loose over Germany. We all felt it, she said, every woman on that line. We knew those planes were going into combat. We knew men were going to die if we made mistakes. That's why we paid such close attention. That's why we caught things the engineers missed. We were terrified of letting them down. The story of American war production is usually told in terms of numbers, tanks and aircraft and ships and guns, counted in the thousands and tens of thousands. But behind every number was a human being, someone who built the weapon, someone who used the weapon, someone whose life depended on whether the weapon worked. The women who worked in America's war factories understood this connection in a way that production statistics can never capture. They weren't just building machines, they were protecting people they loved, and that love made them fierce guardians of quality. Margaret Sullivan never received a medal. Her name isn't in the history books. She lived a quiet life and died in 2001, surrounded by the family she had raised. But somewhere over Europe in 1943, a B-17 flew through weather that would have torn apart a flawed aircraft. It flew because Margaret paid attention. It flew because she asked questions. It flew because she refused to accept that something was fine just because everyone said it was fine. The crew of that aircraft never knew her name. They never knew that a 19-year-old girl from Kansas had saved their lives. They just knew that their B-17 brought them home. That was enough for Margaret. It had to be.